Hi, my name is Bob Greenyer and I'm a volunteer with Martin Fleischmann Memorial Project. So welcome everybody to today's presentation. I have something for you, hopefully a number of things. If we don't get through to the point that I want to today, then we will need to cut it short and go to another day. The presentation that I wanted to do is not the presentation that I started building in the middle of the week, and that's not even the presentation that I'm going to give you now. This is I live my life on a need-to-know basis, and as new things come in and they make sense, it's important to get those things out there for consideration. And so the work with the ultrasonics led to some interesting developments. And I just want to talk through some of those in the context of what we've already shared in the past and how that correlates to other things in terms of potential reactor design and so forth. So if we can get through what I was originally going to do today, I'm going to reveal slide 90 from Ode. If we can go do a little bit more, it's going to be seriously winging it at the end. But I think for the sake of Dave and Henk and those other people that want to come on board with doing VEGA experiments, it's really important that I get this insight out there, because it's been there for a long time and it just really needs to be public now, and so that they can understand where I'm coming from with certain things. Certain things that I say today will they'll automatically have things racing through their heads. So this is going to be quite interesting from that point. Just let me know, is the sound okay? Are we 5 by 5? Excellent. Sound is loud and clear. Okay. So I guess the first question I have for everyone is, what do they think that the cover slide is here? What do you think that I've got there in the background, and why do you think I've put it there? Have I got an echo? Okay, really? I've got an echo. I've only got one mic going in there. It might be an echo in the room. If I get closer to the mic, it might squelch that down. Okay. Is that Teflon? Steak! Very good, Mr. Decker. That is steak, but specifically, what am I showing you? What am I showing you there? In fact, it's actually part of a pork joint. No, this is not aluminium foil. No, Mr. Decker was closest. Ligaments, very close. I am showing you a tendon. And why am I showing you a tendon? Why am I showing you a tendon? Yeah, it's a tendon is like a ligament. It's like it's a very tough thing in your body, in animals' bodies, that is able to transfer the contraction of muscles onto bones and joints. What do you win? you win. Hello, Gert. Well done from me. That's as best as I can do right now. So the tendon form is important, but now why have I not got a mouse? So I'm going to switch back to my mouse is not big enough at the moment, so I'm going to switch back to my ugly mug, and I'm going to change the mouse scale here so that those that want to see my mouse can see my mouse. So give me a second. So yes, it's a tendon, and the reason I'm showing a tendon is because something to do with electric, something that's the title of this presentation. It's called Something Electric. Why would I be showing a tendon? Why would I be showing a tendon? Something electric. Why would I be showing a tendon? One of those. And I want to do that all the time. Okay. I have a nice big mouse pointer now, so everyone can see where I'm pointing. Okay. What? Yes, Mr. WP4 Truth. It is piezoelectric. So the subject of this title is, this presentation is something electric. Something electric. What other types of something electric can you have? What other kinds of something electric can you have? Okay, we'll just, for now, we will deal with piezoelectric. So the first slide here, I've shamelessly grabbed this slide off someone else's presentation in the interests of science. And naturally occurring piezoelectric materials, you can see a selection here: cane sugar, Rochelle salt, tourmaline somewhere, so tourmaline here, and even bone and dentine and enamel, even DNA. DNA is piezoelectric. So that means it's both a receiver and a transmitter. And of course, our favourite is, if I take rid of my mugshot there, our favourite is quartz. Yes, quartz, which is comprised of the number 1 and number 2 most abundant elements in the Earth's crust. So there's a lot of this in every rock. It might not be beautiful crystals like this, but there might be little crystals that are beautiful, like this. And what can we do with quartz? Well, we can, let's see if I can get this right. We can go, we can burn! No, we can light some gas, okay? This produces a spark. Maybe you can, or maybe you cannot see that here. Maybe I'm going to burn myself. Maybe you can see it. I found this in the park earlier. So thank you for the person that dropped it. It was very helpful. Anyway, so there's a piezo crystal in here, and when it gets hit by the hammer, it produces a spark. And as we know, every spark has an exotic vacuum object in it at its leading edge. So we are producing exotic vacuum objects. Now, the other thing is that amber is piezoelectric. Amber is piezoelectric. And why is that very interesting? Well, that is interesting because the Greek name for amber is Electron. As the ancient Greeks thought amber to be pieces of the sun broken off and fallen into the ocean. Due to the piezoelectric property of amber, it will obtain a negative electric charge when rubbed. The quantum particle electron was named after amber. So there we go, I've got the source down there. You can get that when you get the presentation slides. So we have a situation here where the actual name electron is the Greek word for amber, and amber, when you rub it, creates piezoelectricity, and it's all tied together. And my next slide is called the cat's whiskers. And the reason being is that well, it's not just that the Egyptians revered cats. Ken Shoulders says that Egyptians could have produced exotic vacuum objects because available to them at the time was copper, beeswax, and cat's hair. Copper can store exotic vacuum objects. Beeswax is a very good insulator. And cat's hair is an extremely, extremely good producer of static electricity. And I have to have a moment here with you because for the first time in my life, I was going to do a demonstration where I rub a balloon on my head. In fact, I've been wanting to do this for a very, very long time. Rubbing a balloon on my head and then sticking it to the wall and saying, oh, it's static electricity. But I happened to look up static electricity on YouTube. And of course, if it possibly can, YouTube will link you to a cat video. And I found myself looking at cats being rubbed with balloons and the balloons being stuck on the cats. And in one video, it's like chasing the dog's tail, but it's not. It's chasing a balloon that's stuck to its back. And in another one, the guy is putting like loads of balloons on the back of a cat. So I have to admit, I, for the first time, looked at a cat video, not the one on the fat, and everyone's seen that, but I looked at a cat video on YouTube, and I laughed, and I found myself wanting to see more, and I thought, oh no, it's at the end! So, before everyone rushes off and looks at cat videos, there's a reason why I'm telling you this. Basically, another thing is that brass was claimed to have been observed from 1400 BC. This will make sense, hopefully, by the end of the presentation. And it contains both copper and zinc. Copper and zinc, okay? And Hutchison, if we go back to the previous slide, was always using, he created this thing called the crystal cell. And apparently in a Japanese museum or exhibit somewhere in Japan, they have one of these crystal cells that John Hutchison made, and it's continually producing electricity. And he's done some recent videos on this in his new laboratory. And it is interesting that when you think about it, it's one of the natural piezoelectric materials. The other thing is John Hutchison seemed to be extremely fascinated with is barium titanate. Now, why all of this fascination? Hold on, I don't know why it's saying. Okay, are we still live? It just said at the end stream, but I don't think it's ended. Why all this fascination with different static electricities that I'm talking about here? Well, I'm going to find you this document, and you can go and look at it yourself. So go to rexresearch.com shoulders and look for short range electron attractive force, and I'm going to read it, so just let me get that for you and I will be back with you in a second. Okay. It's not going to be nice for me, is it? You can go and find it whilst we're talking here, or not talking. Okay. So, short range attractive force by Ken Shoulders. Statement of action. There is an attractive force found between closely spaced free electrons inside of the universally touted repulsion force. This attractive force is effective only at dimensions in the order of atomic spacing, being in the range of 10 to the minus 10 meters, leaving older repulsion laws intact for large spacing. When this force binds two or more electrons. Now, hold that in mind. Two. You bind two electrons together. Obviously, if you're going to have anything binding together, you have to have at least two of them. But when you have two binding together, that is a Cooper pair. Their expressed field at a distance is reduced. Field, I imagine that's at least the electric field, maybe magnetic field, but electric field. This is a newfound property of this otherwise well-known particle. The effect, as shown by many writings of the author, Ken Shoulders, as well as G.H. Messiatz. Now, Messiatz, by some measure, actually discovered these effects before Ken Shoulders, or at least ways to generate them. However, he wasn't able to characterize them in the way that Ken Shoulders did, and really just the formation of them. But there's an amazing body of work out there by him, and I've wanted to delve into that for actually a number of years and walk through what he observed and how it plays with other things that we've observed. And I will do that in time. But for the sake of this presentation, you can believe that there's a guy in Russia called Messiatz, and he also observed these structures. Electrons easily cluster into complex structures having unique properties not available to single electrons. These electron clusters have been named EVs, or exotic vacuum objects, EVOs, or electron validium, that's strong electron in Latin, or exotic vacuum objects, by Shoulders in various papers available for download from It's Not, because it was taken down, and Ectons by Messiats. There are several theories for their existence mentioned in associated literature references, but a complete description is still lacking. Whatever the effect is that fosters this electron clustering action, it behaves like an unseen substance that enshrouds electron groups, partly masking their charge. It is a short-range force, resembling a positive charge, negating the effect of repulsive electronic charge, and can further be defined as a near-field effect that seems to be an innate property of the electron, occurring at the time of its creation. The local action is reminiscent of the induction field in electromagnetic theory. This attractive force is a property of the individual electron and not a large group effect, as it extends down in size to electron pairs, as is seen in the electron accretion method of forming exotic vacuum objects, described early on by Shoulders in an issued patent and the references cited above. Okay, now he goes into the non-discovery of this, i.e. how it wasn't discovered. And I love this. I love the way he kind of puts this across. Non-discovery sequence. All references cited above show accumulated evidence for the existence of exotic vacuum objects in various sizes and forms. Seeing the large total of accumulated evidence over such a long period of time brings up the question of how finding it was passed over for so long. A citation on how this likely happened is given below. From the earliest realm of electrical investigation, using cat hair and amber, through the more technically advanced era of silk and glass rod, it was determined that like charges always repel. What should have been a temporary guideline using this data was erroneously cast in cement as sacred truth and immutable law by fakers. Fakers are kind of like it's basically so religious. They're like the whirling dervishes. They're a class of people who believe that this is the law and you can't challenge it. And immutable law by fakers, crying from the scientific Tower of Babel. This belief persisted throughout the very technical age of arc and spark investigation, in spite of astounding but unheeded evidence of charge accretion appearing everywhere in the so-called cathode spot phenomena. Everywhere. Have I got the book here? I don't have it. I have the book that he's referring to. And this work was done, I think, in the US from 1932. And it's a summary of that work. And I have the copy of that reference that he's kind of alluding to there. But basically, you are going to get this electron accretion. He talks about it in Tesla brushes, as some people call it, but the filaments you get in a Tesla ball. The old law of like charge repulsion is good, but not all-encompassing, because at any one time there are likely more free electrons adhering to each other in this world than there are being repelled by each other. Electron clusters are ubiquitous. When the electron clustering effect was first found by the author, its mention to all others was treated as scientific sacrilege, as the message from the faker was still echoing through the halls after these many years. The message here is, believe what your senses tell you, and not what others say. What I see is that the like charge between electrons more often attracts than repels, whenever the spacing between them is small. And on that note, I'll go back to the presentation I gave of the paper that was presented, I think in 1999, somewhere between 1999 and 2001 by Matsumoto, where he's talking about producing these things using a linear accelerator and a means of bunching electrons. He's basically saying you bunch some protons from your LINAC and you bunch some electrons, and the two of them will form what he calls itonic clusters. And so if you have a scenario where you have bountiful production of electrons, and they have to be emitted from confined space, essentially what Ken Shoulders is saying, you are going to get exotic vacuum objects synthesized. And exotic vacuum objects like to aggregate. That's what they do. You can see it in the VEGA experiments. Okay, so back to the presentation. Before I do that, have you got any questions? Ah, you're already getting there. Okay. Okay, all right. So let's go back here. So what I've done is I've talked about the Egyptians revering cats. Why? Ken Shoulders said that Egyptians could have produced exotic vacuum objects with copper, beeswax and cat's hair, and copper disc beeswax to bind the rope, a rope of it, and spin. I just threw that in there because I imagined that someone sent a video to me a few days ago and said, "Oh, what about this?" And it was like someone was cutting a box in out of a granite-based material, I think it was, and it had this particular surface to it, and it was only part done, and like part of it was not cut off, but you could see the cut line. And I imagine just almost like a copper disc with beeswax in a groove, and then like a braided rope of cat hair around it. It may not be that simple, but it may be that simple. Because the cat hair with the friction on the quartz, and the quartz itself, and the oscillation and everything, and the beeswax doing the... This doesn't need to be a hot process, by the way. It does not need to be a hot process. It can happen in a cool way. But anyway, we'll move on. So, I talked about Hestalan ball lightning, and the thing is, what has Hestalan got in it? Well, the interesting thing is Hestalan is part of a mineral-rich area. You will have quartz in there, but it also has copper, it has zinc, and it has cadmium and aluminium. Well, zinc oxide is piezoelectric, and cadmium-doped zinc oxide can directly produce electrons in photovoltaic process. I've got links to both of these articles here, and so you can have a look at that in your own time. Copper and aluminium metal to store exotic vacuum objects and allow their aggregation. After threshold reached in right environment, ball lightning produced. So I said when I did the Hestalan ball lightning study that I believe something about the geology, the freeze thaw, the fact that it can get to warm temperatures in the summer, but it can go down to like -40, -50 or something in the winter, and you have these day-night shifts in temperature. You've got a lot of rock compression and expansion, and also you've got the pole is quite close to the pole, so you've got strange radiation coming in natural quanta, and you have ions and all that gubbins going on up in the high part of the planet, and you have these specific minerals here containing copper, zinc, and cadmium and aluminium in this particular region of Hestalan. I've got a link to the region there, so you can go and verify that. But it has zinc, which I think is very, very interesting. But before I go on to that, I want to refer to the work we did in our last presentation. So I'm just going to get up the video on that so that I can just show you something there. So our last live presentation was to do with what I call Shockwave, and hopefully I can not make you suffer that. Okay. Anyway, in the paper that was done by some Mexican researchers, if I can pull this up here. Okay. In the paper that was done by some Mexican researchers, they found that they had lead disappearing. Now, I have to say, Camilla Berna has contacted them, and they say they think they found where the lead went. I don't know what that means. I really don't know what that means. But they say they think they found where the lead has gone. Okay, that being said, the structure of these things is interesting, and they state that the lead was not in the packet, and the actual bits left in the packet didn't account for more than 25% of the material that had disappeared. Okay, so with that in mind, we will look at the next slide, because I'm going to hazard a guess at the process that might have taken that lead out. And to do that, I'm going to do this, and we're going to go, no, on click. Oh dear. Just give me 1 second. Okay. So, I am going to say that I am of the opinion that if that lead really has disappeared, that it is due to a piezoelectric effect. So, the lead oxide layer is piezoelectric. Okay, so you have lead and you have a thin layer of oxide, okay, on that. That is piezoelectric. This would convert sound into electric charge that would not dissipate in the plastic sleeve. That's important. When John Hutchison was doing his samples, he would always put them on a non-conductive material. It would be either wood, or it would be a plastic crate. So here's one of his samples. And so this would be sitting on a piece of wood or a plastic crate, and the field effects were going on with the biasing of the vacuum with the HV, and that would lead to the effects. And so what I'm saying is that essentially the lead oxide is converting the ultrasound into electrons and or coherent electrons, and these would self-organize into exotic vacuum objects. The smallest EVO, in my opinion, is actually a Cooper pair. And as you get this condensation process of bigger and bigger quanta, you get this release of 2 kiloelectron volt X-rays. And higher energy X-rays can be released when the EVOs dishevel. Now, why is that important? Well, what's important there is they actually observed X-rays coming out, and they recorded it on X-ray film, a bit like this stuff. And then they found that the X-rays were actually quite high in terms of energy. And for me, that would be exotic vacuum objects that are blowing up, and they are producing the high energy exotic X-rays. So you have a scenario where the lead oxide is producing a means to an end. I think that this may have happened with copper, which has an issue, but copper oxide can work in a different way. But anyway, the copper didn't have, as far as I understand it, the piece of material disappearing. So I think that the effect is much more extreme in the case of the lead with the lead oxide. So they observed the X-rays and the high energy X-rays and material disappearing. So what I'm saying is that the lead oxide converts the X-rays to electron hole pairs. And I've got a separate paper here, and we can go and have a look at these. But this paper here shows that lead oxide, a thin layer of lead oxide, can directly convert X-rays to electron hole pairs, so like emitting electrons. So in this case, we've got a piezoelectric effect doing the production of electrons, which feed the EVOs, because EVOs need electrons. And in this effect, we have a photoelectric effect. So this is it's a twofer on this, and so you're getting electrons coming out there, and they provide a charge separation feedback loop, because if it's emitting electrons and they're being consumed by the EVO, they're throwing out more 2 kiloelectron volt photons, and that's producing more electrons and so on. So you've got a feedback loop, and that basically feeds the EVOs, and then they have the ability to dissipate, discharge in. They don't have the ability to dissipate or discharge in the plastic sleeve, leading to their aggregation. So it's kind of like you're starting off with the piezo effect. The piezo effect is always there whilst the sound is there. As you do more pulses, they do 250 pulses typically for these lead disappearing. That creates the production of electrons. The electrons produce the EVOs. The EVOs can then, as they condense, they form these 2 kiloelectron volt photons. The photons are then converted by the lead oxide, and so on. So you've got some sort of self-feedback going on here. And then coherence is reached, and the lead becomes part of the macro EVO. So all of the lead that's in that zone, or a proportion of it, gets to the point of being consumed by the EVO within the plastic pouch. And the lead and oxygen, that being the lead oxide on the surface of the lead, at the focus of the sound is captured into the EVO, and there is no means to produce more free electrons. So at the point of focus of the pulses of sound, once that zone has gone, it doesn't have that zone there with the lead oxide and the lead to actually continue to go and produce that. So this is a hypothesis, and I'm saying that the matter may be converted into a range of elements or remain as dark matter. Or, so what it might happen is it converts into gas, and so there might be a change in volume of gas in there. And we could go to the MFMP's linear calculator, and developed by Philip Power and started with the work of Alexander Parkhomov. We could use that to maybe assess which gases might, or for instance, noble gases, or even just oxygen or whatever, that might be synthesized there. And then when they opened the pouch, the gases came out. And they weren't aware of that had happened. Or it might have even been a lot of hydrogen got produced, or helium, and they were able to leak through the plastic, possibly. That's a possibility. Anyway, so I'm suggesting that maybe some of the matter is converted into a range of elements, including gases that leak away, or they might convert into dark matter. What is dark matter? Well, dark matter in this case would be matter that's able to exist in there, but you couldn't see it and you couldn't weigh it, because it's encapsulated in exotic vacuum objects, weighs nothing, and actually goes into live in the rest of the lead that's there. Okay, goes to live in the rest of the lead that's there. So the lead has lost weight, but material in there is trapped inside EVOs in the lead. And I would be interested to find out if they exposed that lead to, for instance, laser light, or heat's not so easy because lead melts at low temperature, but if they can expose it to laser light, would they end up getting strained radiation emissions from it? Or the EVO charge lowers to the point of being neutral, and the EVO leaves the package. So it just walks right through the material and it gets lost. So are there any questions at this stage? Oh, I love your conversation here. It's great. Well, I'm going to address it. You've got some great questions. Really, absolutely fantastic questions. And I'll try and address those in a little while. Let's make a bit more progress on what I wanted to share with you tonight. So next up is zinc. So zinc we had in the experiments, in the Ohmasa experiments, 10 yen coin, and that contains zinc. We had that in the VEGA experiments with the brass, and the brass seemed to be extremely active. We found that the brass, when you had sheets together and with a distance between them, Henk was able to produce this structure, which we call the VEGA valley. So this is brass, and you can see that it's not so clean, and you know, maybe that's important. Brass contains zinc and copper, and zinc oxide in the worksite structure, single crystals of, are piezoelectric and pyroelectric. Piezoelectric and pyroelectric, and copper oxides as formed in lion are photoelectric. So I talked about there being some sort of level of photoelectricity here, converting the X-rays here into electron hole pairs. Well, in the case of copper oxides, guess what? So what I was referring to there, you missed it because I was I was saying that here the lead oxide convert X-rays, which are photons, the 2 kiloelectron volt X-rays that the cohering matter does in exotic vacuum objects, to electron hole pairs. So it's producing electrons. So I'm saying that that is similar to copper oxide. And here is the kicker here. Copper oxides, and I will show in the write-up of this presentation, CuO, Cu2O, whatever, the same stuff that we found in the crust of lion. The same stuff that we found in the crust of lion. Copper oxides have a photoemission energy level below 2 keV. I think it's somewhere below 950 EV, maybe below 980 EV, which means that copper, if we have copper in this, which we do because it's brass, and we have oxides on it, and we know it does, then as the EVOs are forming, and so you basically have layers of brass on top of each other here, and then you have a little fine gap. So you've got plenty of opportunity for electron bunching, with little field between the brass plates and a stronger field in the gap, and the electrons only can go to the gap, okay? And you have copper oxides on here. As the EVOs are forming, they're emitting these 2 keV photons, and they are able to interact with the copper oxide and produce photoemission. So you're getting like a gain there, okay? And so hopefully by the end of this presentation, I will be able to use this piece of paper, and we'll design a few energy producing reactors, which I think will be quite fun. If not today, then we'll do that tomorrow. Okay, so I have where is it? 10 yen coin. We'll address that first. Okay, I've just talked a bit about this, and I think you can probably get that. Is that clear to everyone? Axel, it's not just the bosonova that produces the X-rays. The X-rays, soft X-rays up to 2 keV, are produced when the electrons are condensing, okay, into the coherent matter. Okay, so well characterized. It's not only X-rays, it's UV as well. And I'll talk about something that we can use later down the line, actually employing the UV as well. But Ken Shoulders spelt this out. He spelt out what you could and you couldn't do with this technology, and he really gave us all we need to know. We just had to be listening. Okay, but the fact that we can actually see what's going on with our VEGA experiments is really quite nice. Okay, so the next slide that I have here is an old slide, and it's one of the examples of the way that the 10 yen coin exposed to Ohmasa gas showed us Lena in action. And I like this one because it's got quite a bit going on. The first one is that basically, we've talked about these structures at length, but the actual coin has 95% copper, but it also has 3 to 4% of zinc. Now, copper is paramagnetic nuclei, and zinc is diamagnetic nuclei. So it doesn't surprise me why the zinc doesn't seem to be eaten. So when we looked at this structure, and I will go into much more depth with this, when we looked at this structure here, this ring structure, there's a dome cut out of it, and the dome is copper, and all of this area around here is zinc rich, and this little bit here is zinc rich, but it's got this copper around the outside on the inside, so it's almost like it was churning the material. The copper was disappearing, but it was leaving the zinc behind, and it would appear that the zinc is moving away from a very highly magnetic structure. Because it is diamagnetic, in my view, and the copper is being attracted and being consumed by it more readily. And that would lead to the point that you are, as it's consuming that matter and the electrons within that matter, the condensation process would produce exotic vacuum objects, and that would produce 2 kiloelectron volt photons. And the 2 kiloelectron volt photons would interact with the zinc. And I can tell you, there's zinc and oxygen there. So if we look at this sample here, I think, yeah, so this little fleck that you see here on this, what I call a cobblestone, this is a little bit of the crust of the kind of zinc oxide that's around the outside here. Okay, so you can see if we look at that crust, a number 100, it has zinc 13.7% and oxygen 30%. It's the highest level of oxygen, and it's the highest level of zinc in this fleck. Okay, and you can see, where is it? The fleck is here on the smaller frame. So what I'm saying is potentially that the heat that's generated by the consumption of this and the emission of the photons, what I'm saying is, where is it? Zinc oxide, it is piezoelectric and pyroelectric. So I'm saying here, when the heat is generated, the electrons, the 2 kiloelectron volt photons interact with the copper oxide, which is this bit. So this is all copper oxide on here. So we look at any of these areas here. So let's look at 99. You have copper 49%, okay, 49 by atomic concentration, 49, and you have oxygen here. So copper and oxygen, okay. And so this is copper, but with an oxide layer on the surface. And so that is photoelectric. That means that when the exotic vacuum object, which is doing all of this work that we see here, let's assume that's the case, and it's being fed electrons, they're condensing, producing the 2 kiloelectron volt photons. They are producing electrons by interacting with this copper oxide layer, therefore perpetuating the life and agility and vitality of the exotic vacuum object. And that is then causing some heating because there is transmutation going on here, and we know there's transmutation because these little snowballs on here, these little snowballs are converting oxygen. So for instance, the oxygen here on 99 on the surface is whatever. Anyway, you're getting sulfur produced here, and there's obviously oxygen in the air and there's oxygen in the gas. But anyway, there's no sulfur in the metal, there's no sulfur in the gas, and that's it. That's all there is. So sulfur is being synthesized in these little balls. So these are actually little exotic vacuum objects, which probably were left over from the macro exotic vacuum object that was here, and these are getting electrons pyroelectrically from the zinc oxide around here, and photoelectrically from the copper oxide. And so there we go. We got photoelectric and what do you call it? Photoelectric and thermoelectric. So we've done piezoelectric. We've done piezoelectric in ball lightning and so forth. In Hestalan, We've done photoelectric, and in the Mexican study with the lead oxide, we've done photoelectric and thermoelectric. So that's why this is called something electric, this presentation. Could have worked a bit better on getting my worms out today. Now, after the last presentation, I forget his name now, and I'm going to find it out. I think it's, let me just get that right. I want to give credit to the person that sent me this link. And I was actually writing this at the time, so it was fascinating that he came through with that link, and kind of like, okay, I'll do something different. His name is Jacob, so thank you, Jacob, for sending me this link. And what I'm referring to is this, and it is water splitting. And this is a paper from 2010. And what they found was when they made crystals like you see on the right here of zinc oxide, with these highly dendritic spiky structures, which we've seen in other technologies, by the way. We've seen in other technologies spiky dendritic structures. Think about that for a minute. That the cavitation leads to coherent matter, in my view, due to charge separation. And Shoulders was very clear about this. So we're going to basically, in the sonofusion method, Ken Shoulders says that whenever you get a cavitation bubble, you will get charge separation necessarily. Okay? And that would lead to the formation of exotic vacuum objects. And they are saying in this paper that the cavitation, they literally say in this paper that the ultrasonics, in combination with the zinc oxide, which is a piezoelectric material, so they've got ultrasonics going into water with the zinc oxide, they're saying that the dendritic structures allow for charge separation. So in 2010, when this paper was published, they are specifically saying that it promotes charge separation. And Shoulders is saying that whenever you get charge separation, it doesn't matter where it occurs, you are going to have exotic vacuum objects forming. And so you can imagine a similar situation with the work of Stanley Meyer. Okay, so this was announced March the 23rd, 2010. So I'm going to find you a reference where Ken Shoulders is talking about sonofusion and how that is related. Okay, just so you know, I'm not making it up. Okay. So, this is from a paper called Low Voltage Nuclear Transmutation, and it has this slide which says cold fusion. Thermal cycling method has exotic vacuum object evidence. Gas discharge method has exotic vacuum object evidence. Electrolytic method has exotic vacuum object evidence. And the sonic, i.e. what we've been doing with discussing the ultra experiments and the work particularly of Roger Stringham and the replication work of Tom Claytor, which shows the same kind of elements that we synthesized and the same kind of elements that we observed synthesized in Suhas-Ralkar's reactor. I am fully behind this statement here. Sonic method has exotic vacuum object evidence. And we will address something that he says in this next slide. All listed technologies utilize EVOs as base technology. Thermal output capability only by destruction. Thermal output capability only by destruction. Ken, I slightly differ. I agree and I disagree. You can make a reactor that can produce heat, and the destruction is confined in a way that it doesn't affect the reactor's operation for a period of time. And I argued that with Suhas-Ralkar's Echo fuel reactor, where he had, when he produced the fuel, he put it with a corona discharge and ultrasonics. And the way the reactor was structured is that when the ceramics get perforated, it doesn't really damage the reactor's ability to function, because it's in an overall chamber with hydrogen, and he has constant water, which is iron rich, flowing through there, so he's bleeding away exotic vacuum objects so they don't build up to the point of overall total destruction. Although I would imagine that there would be failures in time, but not quite as common as is observed when people try to create more excess heat. Eventually the exotic vacuum objects will just destroy the reactor. So Ken, yes, to all intents and purposes, the thermal output, you can get thermal output, but you have to sacrifice your structure. It just will destroy it. Electrical output without device destruction. I'm hoping that we can get to that within this presentation, and we can use this piece of paper to show you how to make a couple of reactors designs, and maybe even give you some parts you can buy off eBay and plumbing supplies that you can have a go. I'm not saying it'll work, but I think hopefully if we can get to the point either today or tomorrow, you will just see enough to know what is possible. And okay, so I'm going to also here, with proper design, Hutchison effect could function as a claimed at the low power actually used, and I fully believe that's the case. And he clarifies here, the energetics of these technologies all have a common basis in electron clustering, plasma focus, Hutchison effect, Adamenko work, Evo energy production and transmutation and cold fusion. And I agree, Ken, what a pioneer, what a pioneer. Okay, let me go back to the presentation. So at the beginning of this presentation, I shared this, which is a paper that I read in, I think it was 2016 or 2015, and I have to be honest, this is one of those papers where I should have immediately gone out there and just made it public, and the reason that I'm producing these videos right now is I'm sorry, I made a mistake. I should not put this out there immediately. And I learned my lesson about that, and so that's why you're getting some raw presentations here. And I will take a little break into next week, because I've got a backlog of presentations I've actually done, and I need to fill those out with all the references. So you will get those and the extra content. Anyway, the point about this paper here is that the person that did this work at Professor K. Stevens at the Department of Physics, University of Nottingham, found that if you took a piece of quartz and flat-ended, and you had to have the end of the rod must be flat and parallel to less than the wavelength of the sound, so you had to make these fairly good for this to work reliably, then you could put microwaves into one end of the rod, and it would travel down the rod. It would convert the microwaves into a soliton of sound, but the packet inside that soliton actually has the microwave frequencies, and it will travel at the speed of sound through quartz, reflect off the back end, and come back and give little pulses. I call this chirps, but then some radio guy, if actually Alan said, chirps is a different phrase in radio terminology, so we won't call it chirps. I originally called it chirps, but little pulses of the original RF frequency in RF in the microwave range. And so it's acting as a transducer that is able to not only convert electrons, sound, light in the microwave range into a sound packet. You can imagine that this would effectively work at any frequency, and we know from our piezo device here, we know that spark you're hearing there, that spark is the noise is the hammer hitting the crystal, and that's producing the spark. And so at certain frequencies, you will have electrons emitted. And so we'll have a quick look at that paper. I've done it before, but let me just get that one up. I have it here somewhere in a browser window, I think. Yes. So let's see if I can pull that up there. Is it going to let me do that? Okay. Yes, it is. Good. Okay. Okay, so the new ultrasonics. Fascinating opportunities for research into sound waves of unprecedented frequencies, 10,000 megacycles. And over here he says, blah, 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 blah. He says you can even get higher than that. He says, thus, as far as we can see at present, experiments with microwave ultrasonics will have to be performed in liquid helium temperatures. That's one thing that they say there. He says, okay, so there is a strong probability that the same will be true for any dielectric crystal up to 1 million megacycles per second. Above this frequency, there is a natural cutoff when the ultrasonic wavelength becomes comparable with the interatomic spacing. That might actually be quite important. Anyway, so this is the little device. You can see a threepenny bit here for those coin collectors. And here are the pulses you get, and the gap between them is the time it takes for the sound packet, the soliton containing the microwave information, to travel from one point to the other. And it's quite fascinating. And then there's a car that you could buy at the time for £573. Bargain. Okay. Okay, let me get back. So I have a link in the presentation where you can see, if you go to my original video, you can see, if you go to this original video, I've got other links in there that you can go and look at that. So then I want to share with you, whilst I shared this for the first time in discussion with the supernova reactor on the 26th of March 2020, I actually discussed some of my thinking on the 7th of January 2018 when I visited the 2007 Hutchison lab equipment that had found itself in Germany. And so I will show you the relevant section of that video now. And we can press play here, I think. I don't think you're getting the audio, are you? So let me just pause that and wonder. I know I've got one application running the audio through, but not this application. It's lucky I'm not getting paid for this. Keynote, okay. Keynote running through. Let me see if that's going to work. Okay. I will try now. I can't actually monitor that. That's not good, is it? That's definitely going out. Okay, this might work. Okay. I can't actually see if the audio is playing, so we'll have to see. Okay. Right. There are some Hutchison samples here. This is a large aluminium billet, and this is another billet, same diameter approximately. And one thing I was discussing with them yesterday is that in Hutchison's work, when he shows off a lot of his samples, there tends to be this effect occurring at n lambda plus a half lambda, which is essentially what you use for ultrasonics. And so here you have a half wave
between here and here, potentially, that is causing an effect to occur in the dead center, where the resonance is maximum, and here it's like one third in from the end. And there was some research done, published in 1959 and then in New Scientist, I think in 1964, where they were using up to 10 gigahertz microwave. I think at around about 10 gigahertz, there's something to do with the atomics that means that it doesn't exhibit this effect. But they were using a piece of quartz, and they were shooting microwaves into it, and then turning off the microwave pulse, and from the end where the signal was going in, the microwaves were going into the piezo properties of the quartz, and it was sending a sound wave that had inside that sound wave the frequency that was initially impinging on it, and it would come down, bounce off the impedance mismatch at this end, reflect off there, come out, and then re-emit electromagnetic waves. And you would get pulses, and the pulses were separated by the time it took to travel and reflect down the bar. So essentially what you've got is some sort of overlaid frequency component onto the traveling sound wave, onto the phonon. And so maybe that's something like what's going on in here. All aluminium will have aluminium oxide on it. Does that help with the impedance mismatch from the microwaves coming in to going into the metal? Who knows? But I'll share those papers and publications for consideration. So one thing I was also discussing is that it tended to be cylindrical billets like these, or spheres that were very good for the Hutchison effect. And essentially what I'm seeing therefore, thinking about this, is that you have a resonance that is down the length, which is, as I said, n lambda plus a half, like you would do in Ultrasonic's design. And then you probably have a resonance that's across the diameter. So what Thomas Bearden is saying is that when you get the field interference between two electromagnetic waves, such that where they zero sum, you get electrogravity. And that, in combination with something like the Van de Graaff generator or the Tesla coil up there, potentially is able to create the Hutchison effect. And as I've discussed in previous videos, aluminium seems to be the most susceptible to this effect. And I've suggested that since it's an electron-based effect, and electrons hold the metal lattice together, that the induced, let's say it's charge clusters that are induced into them, affect aluminium because of the low melting point, i.e. its ability to hold the lattice together is lowest in aluminium of the very high melting point, sorry, of the very high conductivity elements. It's number 4 in the list.
Okay, so that was that, and so basically what I was talking about there was how I'm talking over the top. It's not quite finished, is it? It's just finished. So what I'm talking about there is that the I was essentially in that presentation, I was referring to the work that I'd seen from 1963 in that British paper, and it was actually first published a brief overview of it, or around the same time in New Scientist, in fact, and in 1963. But I think the work was done earlier. So I had that in the back of my mind, and I was trying to rationalize how electromagnetic waves could end up becoming sound waves inside a piece of metal, or becoming waves inside a piece of metal that could form nodes and antinodes and build up such intense levels of resonance. And so I came across that paper, by the way, sorry, I came across that paper before I actually had a relationship with John Hutchison and before I'd gone to that lab. But what I'm talking about in that lab, the fact that there must be some sort of piezoelectric material on the surface of that aluminium, or sufficient enough transfer of energy into wave packets that it is able to build up in the material and to come to some sort of resonance. And so that was my thinking that I was trying to get across, but it wasn't very well formed at that time. And now I want to show you something from the Lion reactor here, one of these. And you'll have seen this many times before in my presentations. But essentially it is, this is one of the, I think this is line 2. And this was, line 1 was conducted in the mid of 2017. And line 2 was reasonably shortly after there. And here's our magnetohydrodynamic self-similar structure. Sorry, I'm on the wrong page. So this is the reactor, similar to the one that I've just showed you. And this is our magnetohydrodynamic self-similar structure with substructures of a similar nature. And this is fused quartz, but of course we've got some recrystallization going on because of the interaction here and maybe heat treatment and so forth. And this here is the solenoid heater wire, and the reactor end was up here. This is the reactor end. You can just see this dark shadow up here. So outside of the reactor end and outside of the quartz liner that you see a version of here, this occurred to the material. Now the reason I'm saying this is because in this experiment, Alan Goldwater determined when he got the kit from what was then looking for heat, he got the kit and it came with this power supply. And when Alan looked at the power supply, he found that there was an ultrasonic ripple on it. And he thought, well, that's going to cause us problem in power measurement and so forth. So he replaced that so he would have better control. And also because it was integrated into the data capture system already, the lab power supply that he already had. And so the ultrasonic ripple was taken out of the equation. That may have been, and I've argued this with Jed Rothwell years ago, why our replication, other than the fact that we thought it was around about 830 degrees C, when in fact we found out it later that it was running at about 1050 degrees C, but it may have been a key reason why we did not replicate that first time. And I do hope that we will have another chance to replicate that either here or in the US in the coming years. Anyway, so the point is that we had fused quartz tube which showed some recrystallization. So could there have been a situation where over a period of time you got a scenario where it was able to convert this ultrasonic sound into the kind of piezoelectric property of the quartz, and the quartz was then in contact with the copper, which was slowly oxidizing, and the copper oxide then is photoelectric. And so that is able to take the quanta that are coming out of the quartz and build on that by this force feedback loop. So you've got electrons coming out, EVOs forming and between the quartz and so forth. And then you have the photoelectric effect giving more electrons and so on. And it kind of builds and builds and builds on itself. And then, so basically the conductive metal inside that later become oxides of copper. And the reason I'm saying this, because if you look at this, you have, this is the wire that makes the solenoid. You've got the other terminals for plus and minus on the power, heating power. And the solenoid is wrapped around the quartz, okay? And so you effectively have a piezoelectric material with a power with ultrasonics applied to it over a conductive metal. And you know what that reminds me of? That reminds me of a patent that was published on February the 21st, 2019. A little more than a year later than we first were talking about this structure online. Okay? And so this is February the 21st, 2019. And what do they have in that patent? Well, firstly, it's room temperature superconductivity. Okay? And so we have a helical electromagnetic coil, and it has a pulsed current source. Okay, well, we've got a DC source, but we've got oscillations on top of that at ultrasonics. Okay, and what they have is PZT, which is lead zirconium titanate, or whatever it is. It's the most piezoelectric material there is on a coating on aluminium. Okay, we have a coating on aluminium, and what this does is it produces superconductivity at room temperature. Okay, so this is kind of like an analog of the line reactor, but it's basically what I was saying in this video in whenever it was in the beginning of January 2018, where I'm saying that on this material, if you had some piezoelectric material, you could transfer the energy in and go in there based off what I saw in that work from 1963. And so by Salvatore Pais and the US Navy saying that this produces room temperature superconducting, what they are saying is people who understand about superconductors, they are when you get electrons and they Cooper pair, okay? But you kind of need that everywhere. And if you've got Cooper pairs everywhere, Ken Shoulders is saying that in that surface layer, if they're all everywhere and you've got loads of them, they're going to join together as well. So you're going to have one whole coherent mass. He's saying exactly what I'm arguing at the beginning for how that lead disappears. Because you have lead oxide, which is piezoelectric. And you have ultrasonics going in that are producing these ultrasonic shocks that are producing, I believe, not only are they producing electrons, the electrons are monochromatic, i.e. they are of the same energy, and because it's a shock, they are in phase. So you have monochromatic electrons in phase. What do we need to create coherent matter? We need the same thing. In this case, it's electrons. We need them to have the same energy, and we need them to be in phase. So it is not surprising that the process described by Salvatore Pais is producing lots and lots of coherent electrons. Okay? And what better material than aluminium, it being so conductive and lots of free electrons on it, to act as a reservoir for these electrons. And if the pulses are all producing at the same time a large number of coherent matter, and the coherent matter is in a cluster, according to Shoulders, these things, if they're close enough together, then they will want to join into a bigger cluster until the whole thing is one piece of coherent matter. So you can kind of start to get an idea of where I'm going. Now, I kind of want to go back a little bit to the beginning of where we started this. And let me just see read ahead from where I'm going here. I'm going to ask some questions, answer some questions at the moment, actually, before I go on to the next step here and see where we are. Yes, Jay, you got the Salvatore Pais. You know, it's very interesting. So one of the reasons I'm accelerating releasing material for O-Day is because there are now researchers that are taking it seriously, and they're doing what it should do to show the truth of the matter. And that's a real pleasure to see. But I'm kind of a bit fed up of putting things out there, and then the US Navy or the US military always backdating just to a little bit before I said anything. I'm not saying it's the case, but I'm finding a pattern. Like if you can award something to yourself and no one is able to look at the records apart from the people that are awarding it to themselves, then they can basically patent any idea you can ever come up with and put into the public domain, because they can just backdate the patent application date. You don't know. You don't have control over the system. They just say, oh yeah, it was applied for. Yeah, right. Yeah, okay. And it may have been. But the point is that we put it out there first, and Line did do the work first. And I believe, because actually copper oxides themselves are known to be superconductors, okay? And the other interesting thing is that lead as it's on its own, and I discussed this in my ASTI presentation, lead on its own is one of the highest temperature, critical temperature superconducting materials. So if it's going to become superconducting, it's a good one to become superconducting if for some reason it can get into a favourable state of matter. Okay, so my view is that the powers that be will patent everything, even if you publicly release it. But we've got to make it so simple. It's so simple that anyone can do this. And then it is literally down to tyranny to stop you from changing the path of humanity. We are at a unique opportunity in time, because the narrative has shifted with whatever nonsense is necessary to try and get a lot of economic activity to try and deal with so-called variations in carbon dioxide in the environment and anthropomorphic climate change. Regardless, they're pushing that narrative. But why? They're pushing it to solutions that are not, in my view, the right solution. So that when the knowledge comes out about the real solution, everyone's already solved the energy problem with backwards. I mean, windmills? I mean, seriously? Windmills? I mean, when were windmills invented? Like, a long time ago. Watermills. I'm all for alternative energy where it really is needed and there's no other option. But this technology is real. It is real. And we don't rely on anyone, no big companies. We don't rely on politicians. We have to do this. We have to take ownership of this. And if they try and patent with reverse patent releases, they might have known about it since the 1950s. They might have dug up some historical parchment that said, this is how you do X, Y, and Z with coherent matter from 2,000, 4,000, 5,000, 12,000 years ago. And they kind of worked it out and in whenever it was, and they're trying to keep it strung along, selling us old rope until they can convince us it's a new idea. But it's not a new idea. It's not a new idea. Coherent matter has been there as long as the universe has been here. Okay? It was always there. It's the new eternal fire. It's the new eternal fire. Okay, I'm going to see if there's any questions, and then I'm going to go to the next slide. Okay, dear Don Axe, what piezoelectric material would you like to see in ultrasonics? The best piezoelectric material is PZT. Sorry, it is. Oh, sorry, you can go... You want to find out what's piezoelectric? Go and look at piezoelectric on Wikipedia. They've got all the materials there and all the desperate attempts to try and get something better than PZT. The reason they tried to get rid of PZT is because it's got lead in it, okay? But, it's very good. Even the Salvatore Paya... They're saying, let's have PZT. And it's a metallic coating. It's on the metal. It's on the metal. Why is it on the metal? Because you want the coherent matter to go straight into and accumulate in the metal and kind of self-organize that metal into superconductivity. So even with resonance, would it not just shoot the beam out at the end rather than transmuting the aluminium at the node point? It does all of the above, and it is based on dimensions and the driving energy, frequency, and phase. So, question: if the ancients knew about this, surely the technology should not be so advanced. I don't think it is so advanced. As I said, Ken Shoulders said it was aluminium and copper, beeswax, and cat's hair. That's not advanced. Gardy Pierre, I don't get why they would make fun of Hutchison if his neighbours would call the cops for his antics. He's a funny guy. He's a really funny guy. He's a really funny guy. But people aren't always comfortable around people who have different ways of thinking. Let's put it like that. Dear Don, if you're making PZT, it is toxic, so be careful. Typically, when you get a PZD transducer, it's laminate. It's got a sort of a paint on it, a film on it, to stop it from falling apart, because they do fall apart. So WP for Truth says, everything I've built is from repurposed materials and someone else's garbage, and no one pays for what I've done. It is free. Thank you. That's what I like to hear. Thank you. What John did was he was given a lot of equipment for just putting his time into taking it out of a ship, and he built things from the scrapyard mostly, and from junk sales places. Thunderbolt, I'm starting to think that if Stan Meyer used cavitation and electricity to split HHO. So when you have discharge in water, as Matsumoto was doing, you will get states where you will have some cavitation. There will be some vibration because bubbles are formed. So you will have some cavitation. And what Matsumoto has showed, that doesn't have to be at a high frequency to be able to produce the same effect. In fact, you can get a vacuum vessel. Thunderfoot, I think, has done a video where he gets a vacuum vessel that's partially filled with water, and he just shakes it, and you get cavitation in there. And he's just shaking it like about that oscillation. So you don't need to do a lot. In fact, at ICCF 22, I think there was a Japanese team. Might have been Japanese. I'm sorry if it's an Indian team or another nationality, but they just passed water, flowed water through a series of pipes, and they got cavitation. Okay, so just the point of flowing water and the friction and so forth through. I think they had some narrow channels for it to run through, but whatever. You can get cavitation really rather easily, and if you added ultrasound on there, that can be provided by pulsing the electricity in there. So flow, pulsing, the actual process of electrolyzing water, and also if the gaps are a certain size, they will tend to produce more or less cavitation. Okay, so and if you get the coherent matter, as I've argued before, I believe that just like those examples of ball lightning carrying matter, water, and dumping the water when the ball lightning falls apart, it's not boiled the water, okay? It's below 100 degrees. But when the ball lightning goes into water, it looks like it's boiling the water. Well, is it just boiling the water, or is it actually on that coherent matter sheet? We're going to come on to this. As you go into that coherent zone, right, it might boil it. It is this point, but as it gets closer to the actual coherent matter, it's actually ripping the matter apart. It's ripping the matter apart. And so you will get some, in my view, dissociation. And I believe that what happened in 2010 with that zinc oxide, with that ultrasonics in the water, they will actually be correct. They actually say that it is causing the piezoelectric effect of the zinc oxide in the Wurtzite structure with those dendritic pointy bits. They are causing charge separation, and the charge separation, according to Shoulders, is all you need, and you will get EVOs. You can't do charge separation and not end up with EVOs, basically. And so and EVOs, in my view, are coherent matter. And so the coherent matter, it doesn't matter that it doesn't need to be as big as a ball lightning. It doesn't need to be tens of meters across, like sometimes in Hestalan. You know, it can be micro ball lightning, as observed many times by Matsumoto, and the micro ball lightning coherent surface is splitting the water. Isn't an X-ray an electron laser? No, an X-ray is a energy of X-ray of light, a frequency band of light that's above UV and below gamma, and it's normally something that comes from nuclear processes, but EVOs will generate them. Alan Wilbur asks, Bob, do you know of the Shockwave devices for medical use for healing joints and such? No, I don't, but I'm sure that someone's tried it. Oh, sorry. Yeah, well, I do in terms of the devices that we discussed in the last presentation, Shockwave, but not for the uses of dealing with joints and such. Yeah, there doesn't need to be a spark plug. Modern ones don't have spark plugs. And in fact, the one used in the Mexican study didn't have a spark plug. It's kind of like I had a 5 to 10 minute. How's that even possible? Because you got the sound, and the sound, well, we know the sound is going to create cavitation. Cavitation can create charge separation. That can create EVOs that way. So you didn't need the spark to do it. But I thought, then why is it so focused? Why? Okay, because that could be channeling the exotic vacuum objects formed by the cavitation. But I said, maybe it's more than that. The important thing, I think, is that they were in a plastic container. And that only allows whatever it was packaged in as a residual gas and then the lead, which will have a lead oxide layer on it, and then I go, oh, that's what it is. And that maybe explains why the copper doesn't do much. You can still get the EVOs focusing to a point and producing the X-rays from the copper from the cavitation part of the process. Okay, because you will get cavitation even with the ultrasonics rather than the spark plug ones. But it was the lead disappearing, which is a whole other level. You know, I'll be interested to see what they come up with as they think they know where it went, which I hope to see what that comes out as. Apparently, COVID stopped them from doing research for most of last year, like most of us, really. Bob, is part of this tech healing and ultimately immortality? I think probably yes. But the spirit is immortal anyway, so it's kind of like you're getting stuck in a place, really. When I say immortal, there's always a chance of dying, but the spirit, in my view, doesn't die. So there's one of the wonderful things of this journey is the realization of the truth in that. So I don't fear death. That's also quite useful when you're doing what I'm doing. Axel, that could actually be the case. It could be the transported material that's showing up on the film. In the case of the hydrosonic cavitator that Shishkin was using, it was producing these little birdies, and the birdies were carrying whatever material they traveled through, and they characterized the pit depth and the width based on the material that they... So if they put a different gas... the neutral exotic vacuum objects traveled through that gas, collected ions of that gas, and then when it got to the film, the radiographic film, it would deposit those as impact craters, and the impact craters were very easy to define as the width and the depth based on the weight of the nucleus. So it was carrying those with it, but the actual birdie itself, they were saying, is the influence of the structure on the electrons in the silver based material in there, and it appears as an X-ray. So there's no reason why light couldn't be generated. And in the case of the work of Ken Shoulders, he's saying that it produces 2 kilo electron volt photons, and Shishkin verified, and the team at Dubna verified that produces, when they dishevel, they produce just the normal kind of mushroom shaped ones. When they dishevel, they produce up to 10 kilo electron volt photons. And when you have a large quantity of these things that go to the point of self collapse and boson over, then you can get much higher energy particles. I love you too, guys. All of you. Yeah, Gordon, people age because there's every time a cell splits, there's things called telomeres at the end of the DNA, and they shorten in length. And after a period of time, they're not long enough to stop problems in division. Now, if you were to lengthen the telomeres in some way, you could potentially do it like that. If you could slow the number of divisions, and the way you can increase the divisions is get fat thin, fat thin, fat thin, fat thin, or damage your body, damage your body, damage your body, and it's having to heal and it's having to heal. Anything that causes you to have more cell divisions shortens your life. And so this is why they say that if you have a very low calorie diet, then your body goes into a mode where it kind of survives. And so you live longer because you have very little of the cell division. And I believe this is why the Japanese live so long, because if you've ever been to Japan, the food portions are incredibly small. And I love the Japanese, don't get me wrong, I love the Japanese and I love their food. Instead of using water, would using steam be better catalyst for EVOs? Well, certainly Tesla used dry steam in his death ray, and so what he called electric particles of matter would be emitted from the tungsten wire fed or the mercury liquid cathode and pulsed, and the pulsed that material, the electrons and the material either from the tungsten, which would likely be transmuted as well, or the mercury, would form a stabilized EVO, and that EVO would then travel through dry steam. And so it's likely that would play a role. I know people that are doing water spark discharges, they will spray water mist on there, and someone has done an ultrasonic mister in a channel, and I've got this on my Steemit blog from years ago, up a pipe, so you will get the standing waves in there with the ultrasonics as well, and they've got a spark with the diode hack on a induction coil, and so that's bringing a lot of these things together. So you can see the evidence. You need to do the work to find out whether it's better than doing it straight underwater. Corky, dry steam, never heard of that. Well, that's real steam. If you've got wet steam, then you haven't got real steam. And a lot of researchers, even in the LENR field, have made the mistake of thinking they've got a certain level of excess. It's because you need to get no entrained water. It needs to be the gas of water. Okay, so I think I'm going to go on. So this is for you, Corky, but it is slide 90 from O'Day. And we're going to lead into it with a couple of slides from Ken Shoulders. And we're going to look at his a couple of his papers. And then we're going to go into some records, images from Dr. George Eagley of real ball lightning interactions, compare the two, and we're going to have some considerations on what that might mean. So, cutting stone with sound. That's the subject of what I'm going to be talking about here. So, what you are looking at here, if I get my mouse on the right computer, is the entry side of an EV, well, that's what he called them when he took this photo, electron vanadium. EV strike on silicon carbide. Silicon carbide, if you go and look at the the properties of silicon carbide. Silicon carbide is extremely high temperature. Okay. I believe it's covalent. It might be ionic. I think it's covalent. And silicon carbide is actually what was used, the very first silicon carbide, in the carbon button lamp of Nikola Tesla. I think it was in 1892. Silicon carbide is also the material used in the core of the core of Alexander Parkhomov's 225-day reactor. Okay. So that's on a silicon carbide grain coated on 0.001 inch thick aluminum foil. Okay. And this is the exit side. Okay. Look at the entry side. It's gone in and it's thrown stuff around, and then it's gone through and come out the back side. Exit side of EV strike, electron viridium, or the previous name for exotic vacuum objects, strike on silicon carbide grain coated on this. Okay, so this is from the paper An EVO Scope for Electrolysis Projectile Measurement. And if you go to the link that I gave you before on Rex Research, you can be able to download this paper and have a look at this. The one on the right here is the entrance cross-section of an EV borehole in aluminium oxide. So this is alumina, showing sloshing cycles. So the alumina has been converted into a material that is left in a glassy state as the thing came through. Now, if you had a technology, in my view, that used coherent matter to bore or cut or whatever, you would end up with very glassy sides and glassy edges, and you might end up with different elements at the bottom or on the edges. You would certainly, in my view, end up, if you were using it to cut, if your original material was less, had a lower integrity, you would end up with a layer on the outside, depending on the intensity of the exotic vacuum object tool that you were using. There would be a level of material turned into this glassy-like phase on the outside, but the inner material would be otherwise untouched. Okay, so if you're starting with something like granite, you would have a smoothing off of the surface. You would still have cut lines if you had something that was doing it progressively, i.e. whether it was a beam of exotic vacuum objects or it was something that created exotic vacuum object clusters on its surface. You would have the cut lines as it kind of progressed one cycle beyond the other. But if you had a non-granite material, you had like something that was more like sandstone or whatever, you would still end up with this glassy finish to it. Okay, so this is what we go here, and I'm going to go and dig up some more work from Ken Shoulders to introduce at this point, because I think it's important too. So let's have a look. What are we going to show? Okay, I think this is what we want. Okay. So this is from Charge Clusters in Action. Again, you can get this on Rex Research, and you have here, I maybe zoom into that a little bit more so you can see a little more clarity. You have a EV strike on a 6 micrometer thick aluminum foil, and that's the entry side. And this is EV strike on 6 micrometer thick aluminum foil exit side. So the actual thing has a very tight center section where it's going through, but it does affect a wide area around it. And again, you have this very, very glassy look to it. Now, I've talked about this before, but when I went in 2015 in January, I think it was January, February, first 2 months of 2015 to visit Alexander Parkhomov for the first time in Moscow, I was taken to the Joint Plasma Physics Laboratory, and one Sergei Godin showed me a alumina, might have been mullite, tube that they had been running Parkhomov fuel in. And they said, Bob, come and have a look at this. Come and have a look at this. What do you make of this? We don't understand what's going on here. So they had it sealed at one end, and they had a valve on the other, and they put hydrogen into it. And supposedly it's meant to be hermetically sealed, fully vitrified tube, but it had been through an experiment. And they did, watch this. So they got a lighter, and they held it up to this tube, and they lit it, and all along the length of this tube where the fuel was, or around that kind of area, there were jets, fine jets of hydrogen coming out. And they said, what do you make of that? I didn't have a clue at the time because I didn't know anything about shoulders. But I'm telling you that I believe now it was doing this kind of thing. And this is the cross-section of an exotic vacuum object, boreholes, through 0.5 millimeter thick aluminium oxide plate. That is what you are looking at there. These are boreholes. And so I believe that what they were showing me, whether they knew it or not, and they just wanted to know whether I knew it, but they should have known it, but I don't know whether they did know it, but they were asking me anyway. I believe that exotic vacuum objects were being formed in the Parkhomov fuel, and some of them were migrating out of the reactor. And this is what I'm saying with the Echo fuel, the Echo reactor. His tubes were in a much larger hydrogen chamber. And in fact, that is the innovation that was then moved to with Parkhomov's reactor. He ended up by putting the tube within another tube, within another tube. So he had like a borosilicate tube, then he had an alumina tube, and then he had a quartz tube around that. So the large quartz tube envelope is the overall hydrogen containment. And the inner tube is something for putting the outside thermocouple on. Then you have the thermocouple between the two, and you whatever. But the point being is, you cannot contain exotic vacuum objects. They will do what you're seeing over there, down there. They will do that, and they will bore through. And so, we can. We can accept this because it happens, and I had seen it. So here's this image I showed you earlier. Now, this is again in aluminum oxide, but what are we looking at over here on the right? This is an optical micrograph of EV entrance into lead glass, showing a wave action of sloshing. Here, SEM micrograph of EV entrance into lead glass, showing wave action sloshing. Dual EV entrance into lead glass. You can see the crystal structure of the lead glass here. But what is this? This is an entrance, okay? Do we see a slightly hexagonal shape here? Maybe. Do we see one slightly bigger than the other? One coming out of here into here? And do we see an uppy, an innie, and an outie? Do we see this one being slightly smaller? And do we see an overlap between these things? I think we probably do. And this is glassy. The whole of the material in the Lion reactor, in Lion 1, it was all, the crust is all glassy. It's glassy down to like one, as high as the SEM would go. It was glassy. So, this is the normal crystal structure. So it is converted this to a glassy state. And I think it might be this image here. My point being about highlighting the fact that this was lead glass is that lead glass is the sort of stuff you make crystal glass from, for like decanters and for flowers, okay? The reason it's so beautiful is lead has a high refractive index. I think it's high. Anyway, it does beautiful things with light because of its weight and so forth. But it is a large proportion of lead, but the large proportion of lead in there is actually lead oxide. It's lead oxide. Okay, all right. So anyway, whether that's relevant, I don't know. But the point being is that we go from this kind of crystal structure here to these very smooth phases, these crystal structure around here to these very smooth areas. And so it is doing something that is not really allowing it. It's freezing out, but it's not really allowing it to form any crystals. Okay, and I think this is the phase. I think someone here, maybe I'll just quickly find it because it's not hot. Let me find that. Yes, it is here. Okay. So the people that are saying that this is super duper hot are not. You see, you've got the big circle here, the little circle here, and the two hot spots here. So this is hour 8. Where they're slightly overlapping, and there's one here. This is a magnified view, and you actually see that it's kind of almost like an 8, but it's not perfect. But the point is aluminium oxide has melting point of 2050 degrees centigrade, and yet it has not raised the temperature of the thin substrate material in any perceptible way. Even a thin coating of low temperature wax on the surface to serve as a temperature indicator remains undisturbed unless the aluminum oxide directly contacts it. Additionally, the surface tension of the aluminum oxide fluid is so low that it runs out to an almost atomically thin edge, and there is no indication of evaporation of the aluminum oxide onto immediately adjacent surfaces. So what they're saying is, what he is saying, is that it's a superfluid. It's a superfluid of aluminum oxide, which normally has a melting point of 2050 degrees centigrade. Okay, but it can't even melt, as I understand it, paraffin wax, which is like, what is it, 53 degrees centigrade or something? Can't even melt paraffin wax. This is not necessarily a thermal process. It's a coherent process. It's not a thermal process. It's kind of a resonant process, but it's a resonant matter wave process. It's a process of matter in perfect harmony. Let me go and find the next slide. So here is our things that we were talking about. Now look at the structure here of the exit hole. This is the entry hole, this is the exit hole. And look at also the way that it eats this away here. Okay. Now, what you are looking at here is the aftermath of some ball lightning strikes, and they're supplied by Dr. George Eagley. And if you look, this is, I believe, this is he's got a piece of wire pointing to it. I don't know why, but he is. And you have the exit point. And notice it's slightly off-center. And you notice this vortical mark on the walls. We see these same vortical type structures in the ultra experiments. We see these same vortical type structures in the structures on the inside of the supernova reactor. We see the same type of vortical structures pretty much everywhere we look. Okay? And so these are ball lightning boreholes. Okay? Ball lightning boreholes. And what you're seeing here is a blown up black and white photo of here. And you can see again that this is not just, there's splatter marks here coming in. They're going round there, but like this. And it's like it is this yin yang that I was talking about, this yin yang, but it's also slightly off centered, just like the structure we saw on the top of the Hutchison 1986 ball burn sample. And just like that Hutchison sample, this is a concrete platform which was in front of a house, and below it there was some steel rebar, and the ball lightning tried to get through the concrete to get to the rebar. But look, you have a fairly hard edge here with a slight fall off, and I would say that this is the kind of double layer zone. This is the double layer of the ball lightning. Okay, right? So this is the material that it starts becoming accelerating towards the event horizon, and this is the event horizon. This is the event horizon. So this is, in my view, this is very, very similar to the structure that we saw on the 1986 ball burn sample that I shared with you in a recent presentation. Is this a hexagon type shape? Well, I don't know. It's not perfect. Slightly elongated. I don't know. But anyway, maybe the outside is if you push your imagination a little bit hard. But it's interesting that we have a fairly consistent distance around here, and we observe this on the Hutchison ball burn sample. Now, let's take this image here and have a comparison between that, which is in theory the exit, the entry into the room, but the exit shot of the structure, and compare that to the exit on the silicon carbide of the work of Ken Shoulders. So here we go, we've got EVOs here. This is our exit wound, and this is our exit wound on our ball lightning. And note that it has this kind of bit above, a bit like we saw on that structure on the ball burn sample. Okay, a bit above, okay? And we know that it produces carbon. I would imagine that if they did an elemental analysis of this, this would be a carbon film. And not necessarily just because it went through some sort of paint or whatever. I imagine that there was some sort of transmutation going on. Where I think it came into the room and then it hit up here or it hit down here, and it ended up by leaving these black marks. And I believe that they would be carbon films that are deposited there. I think you can go and delve into the paper, EV scope of, so someone's asked what is this stuff around here? Well, this is entry side of an EV strike on silicon carbide grain coated on thick aluminium foil. So I think maybe you need to go and look into the paper. It's either aluminium or silicon carbide or something that was made from those, and whatever was already in the EVO when it arrived. WP for truth, kind of like how the pyramid blocks are, Bob. Smooth on the surface but grainy on the inside. Absolutely. Would borosilicate glass be a different outcome? In the case of Yul Brown, his jars around his room were crumbly. In the case of our the quartz in this, it ends up getting disrupted. So if you have EVOs going into a material, then and then they destabilize for some reason, they'll smash it up. They'll just turn it to fine dust. As I showed you with the magnetic spheres in a previous presentation, an EVO can go through a material, and if it then comes back into being in white mode, it can consume, and it tends to do that as it goes through the boundary layer. But as I've shown you from the VEGA experiments, the sphere tends to, let's say we've got a VEGA anode and it's like this one here, you will get hemispheres on it. And this is kind of how you can imagine that, let's say there's an EVO on one side here and it travels through. When it gets to the other side, it was comfortable being in the metal because it's got the same resistance, as it were. It's the same material. As it comes out, it kind of gets confused and it gets stuck like half in and half out. And it gets excited, and at that point it then eats a hemisphere behind it and leaves the hemisphere in front and can create a sphere that's half in the surface and half out the surface. And we observed this on one of the outside quartz on the Lion reactor, in fact, and also in the alumina or mullite, or I think it was alumina, of the second tube on our sample from the Alexander Parkhomov 225-day reactor. So those iron spheres that I showed you that go down into that conical thing. You get this conical tail coming out the back. Maybe I'll extend or put some extra slides that the Russians shared about different historical drawings of ball lightning. Where you get the ball, but then you get this cone behind it, which we saw also in the material that was eaten out of the diamond from the lion core, where you got this core of material. And it's core. When I was in my Sochi presentation, I said it's kind of like and it's kind of like it's consuming matter, but it gets unstable, and then it spits out something that's a different element. And it might be a range of elements that's coming out, but it tends to be magnetite, and it depends what's going in, depends its level of excitation. So anyway, so where are we? I can imagine that you could have a coherent matter tool that was almost like an artisan's brush, and you could go and it would be like a little ball on the end, and it would either it would turn the material to gas, and it would just leave it all glassy, the remaining bit. So you could literally work with your hand, or you could have pattern stamps and just put the pattern stamp on there. When you got full control of this material, I mean, I joke about tunnels. You could literally. I might leave that to the second part of the presentation, which I think I'm going to do tomorrow. But I just want to close out on where I am in this part of the presentation, because I've done all the slides for this half, and so I think probably either tomorrow or Tuesday, probably I will do the second half of this presentation, and I think this is gonna be really special. So because it is nearly midnight here. Okay, so where are you? So yes, I'll create some animation of Evos at some point. I did spend most of my professional career before the last 9-10 years working as a volunteer on this, having an animation company. So I do know how to do animation, but I know that there are people out there that are offered to do animation and diagrams, and so we need to spread the workload, because we have a lot to do. Because as I said, I'm getting the feeling that it doesn't matter what you release, there'll always be a pattern that just about predates you mentioning it. Okay, so let me go back to the slide here. So what I'm saying is, therefore, that I think we can fairly safely conclude that what Ken Shoulders is creating here is essentially exactly the same as natural ball lightning. And so I'm now going to reveal slide 90 of O-Day, which was authored in January 2018. And here it is. That is slide 90, slide 90. Okay. And these are my comments here. Construction. There will be no environmental issues with steel synthesis and concrete production. Okay. The reason is because we will have basically unlimited energy, and one of the biggest problems with modern construction is the energy that goes into making concrete, and it's very, very bad. And we're all led to believe it's going to cause the end of the world. So let's remove that. We need to remove all excuses for fear. All excuses for fear. Not using this technology to instill fear, using this technology to remove all excuses for fear. Okay, so so no environmental issues, no difficulty lifting large pieces into place. I think I've probably addressed that in other presentations. I don't think I need to go into that in much more detail, and I probably will at some point, but I think that's done. Liquefaction and moulding of structures. I think I've dealt with that. Particle beam cutting. Now, at the time I wrote this, I'll be honest with you, I hadn't really fully formed the concept of coherent matter. But what I had observed is that that there had to be some sort of beam that was able to literally slice through anything like butter, and that it had to have been either formed of these structures or emitted from them. Later it became very clear that, for instance, if you literally, you could have a lightsaber, but imagine you had, I don't know, a huge RSJ, like an absolutely massive steel joist, a rigid steel joist, and it was completely encased in exotic vacuum objects, like a force shield. Now, it's the same concept that I was talking about, like, you didn't hit me, I didn't hit you, you ran into my fist. It's kind of like, if you had that whole steel beam covered, as I've shown you in Hutchison sample and in a Lion sample, with a skin of exotic vacuum objects, doesn't matter what you throw at it, the matter or the energy will immediately dissipate through the entire coherent matter structure, because you're effectively hitting one atom. It's just very big. It's acting as one thing. And every single part of that surface can dissipate that energy or assimilate it. Okay? So when if you're shooting a bullet at a concrete block, let's say, you've got a highly focused energy. But in this case, if you've got this force shield on there using exotic vacuum objects, doesn't matter whether you're hitting it with a laser, you're hitting it with other exotic vacuum object weaponry, or you're hitting it with a brick, it will dissipate across the whole surface. Now, the brick will be completely consumed instantaneously, just like you saw in the sapphire reactor with the tungsten Langmuir probe, just like you saw in the tungsten coil and copper material in the VEGA experiments conducted by Henk and Dave. So if you can turn that on its head and imagine you had a lightsaber or even a very large steel RSJ, but just let's call it a lightsaber, it could cut clean through a building. It could cut clean through anything. It would. It just wouldn't be very good with things like wood, because wood very quickly becomes carbon, and carbon is very good at being consumed by this. But so I discussed a very long time ago, I stood in front of the Padmaswami temple in India. And in this Padmaswami temple, I discussed the fact that they had this area underground where they had this metal band. And when they went, they found something like 250 billion of treasure in uncut gems and Roman era coins, and from all over China and all over the world, trading of the known world, trading with the Keralites in this Travancore area of southern India, in Kerala, over thousands of years. And it was in these vaults. And when they took the electronic equipment to basically the local space center, the Vikram Space Center just up the road, they were charged and funded to the tune of $5 million to go in and document everything and the location of everything in that vault, in the vaults rather, so they could get the locations and before they started extracting them to classify them and put them under technology to look inside and how they're constructed so they couldn't be swapped out for fakes later down the line. So an incredibly long process. But when they went in there and they took the cameras in and they took their range finders in and everything electronic stopped working. Everything that had any kind of electrical, any kind of semiconductor in it stopped working. And they would bring it out and immediately it would start working again. And then they would take it in and it wouldn't work. And then we'd bring it out and it would work again. And what they found was there was this metal band around the room, okay? And when they cut that metal band, well, they could use all their electronic equipment in there. And this temple is hundreds, if not thousands of years old. How would they know that this technology would stop semiconductors? Well, maybe they didn't. Maybe it's just what this technology does. It disrupts semiconductors. Okay, so so I have here floating bridges. Well, I think maybe I kind of described this where you'd have these like donut-shaped things, and you would charge them up, and they would be able to lift more than their own weight, and that's you put ropes between them, and the ropes are non-conducting, so they can pass through the coherent matter layer easier. And this is kind of like, or a structure that's supported underneath, or whatever, or on the ends, or something like that. A floating bridge where you could ship stuff around, and it would basically weigh nothing, kind of almost like a flying carpet. And so I've kind of described how I see that happening, and the evidence you need is in the chop shop, the Evo chop shop video, where the tungsten is moved, one of the heaviest metals in the periodic table, is moved just by one ball lightning, technologically produced ball lightning. As it falls through space, it's moved along its magnetic pole to align with the one that's still on the anode coil. And so I think you can see what you need to see in that. And then no need for tunnels. And I think probably that is where I'm going to leave this presentation today. I'm sorry we didn't get on to the other material. This, I think it's Skara Brae or something. It's in Northern Ireland. And I'm going to, after I've done the second part of this presentation, talk about the significance of what is codified into here. And I think if you guys think about what we've been discussing in recent weeks, you will know that this is not a carving by chance. This is not guesswork. This is trying to show you how something works. It's trying to show you how something works. Okay, so I'm actually going to come out of that, and I'm going to blow that image up so you can see it full screen, because I think it's that important. So I'm going to make a copy of slide 90 from O'Day. No, I'm just going to copy that onto a new slide. Just a blank one. Skara Brae, so it is. There we go. It's the entrance stone at Skara Brae, so it is. These two, these are good to look at, but it's this group here that I want you to pay special attention to. What is that showing us? What is it showing us? What is it showing us? What did they know? Okay, I'll answer your questions. So just to summarize, let's quickly go back. So we're talking about something electric, and what I'm referring to in part one is piezoelectric, photoelectric, and thermoelectric processes. And we started off by focusing on the piezoelectric, and you could say that maybe the Egyptians used cat's hair and beeswax, but they could have also used smashed up bones, or they could have made a saw out of tendons. I don't know. Here are some of the available things you could try to cut stone with. And you could maybe use a copper tube or a brass tube and get zinc oxide crystals and see if you can cut stone that way. And do you need ultrasonics? Do you need a bow made of tendons? And you go backwards and forwards and that does it, or a disc or something with whatever. But I believe that if you have something that can build up piezoelectrically emitted electrons or thermoelectric, whatever it takes to get electrons in phase and at the same temperature. So I talked about how Egyptians revered cats. Why is that? That Ken Shoulders, I couldn't find the quote, but at some point, I think it was in around about 2006, Ken Shoulders said basically the Egyptians could have done this because they had copper, beeswax, and cat's hair. And as I read you in this document here, he said that it was only because people observed electron repulsion, electric charged things repelling on the macro scale, did the fakers, the people that set the religion of what electrons can do in place, managed to prevent discovery of this for all this time. But Hutchison is very obviously doing a lot of research work on Rochelle salts and with barium titanate. And the fact that Hutchison and Ken Shoulders had these relationships, it's like, did Ken realize this? Was Hutchison channeling the Akashic record? I don't know. I think probably Hutchison would say he is. He just visualized these things in his head and just goes ahead and builds them. I then talked about how the minerals for producing ball lightning are actually in Hestalan, and exactly the minerals, and so therefore it's not surprising that happens. And then I talked about piezoelectrics in the Mexican study, where you had the material disappearing in the lead but not the copper, and I walked through a hypothesis for why that's occurring. And then I talked about zinc being present in Ohmasa tendon experiments, VEGA experiments. By the way, titanium oxide is also piezoelectric, so you need to think on that. But I think zinc is absolutely beautiful from the point of view that it's both piezoelectric and pyroelectric. And so these things are going to be very important when we come to discuss part 2 of this presentation, hopefully tomorrow. And then also copper oxides, and I think this will also be extremely important when we start to discuss part 2 of this presentation. But specifically, I think it may have played a role into why Lion was so successful. And then I gave an example that we've already seen with Ohmasa gas, and I walked through the process of how that could occur. And you have the elemental data there of the starting material and of these what I call snowballs on cobblestones, where they've just got bigger and bigger and bigger as they've kind of eaten the material in front of them, which is copper oxide, and it's produced a sulfur-rich material from fusing two oxygen atoms. And I also discussed the fact that zinc, whilst being only 3 to 4% in the original metal, ends up being in high concentrations in this crust here, where the copper is removed in the disc, and we have the copper and carbon rich ring, and then this is rich in zinc around the outside. This is rich in zinc around the outside, and you can see here the zinc and the fact that is actually zinc oxide there. And so therefore we could have a situation where the material around the outside is producing thermoelectric emissions, and the copper oxide in here from EVO formation is producing a photoelectric support of the exotic vacuum object. Then I spoke about water splitting and Stanley Meyer, and we now know that all forms of cavitation will produce exotic vacuum objects from the charge separation, and that this work that is here, this specifically is talking about how the zinc oxide is responding to the piezoelectric, the piezo-driven ultrasonics in the water, and it's causing charge separation, which is accentuated by its structure. And this, as we know from Ken Shoulders, produces exotic vacuum objects. And so I believe that fits into my discussion with ball lightning about how that is able to cause splitting of water energetically preferentially. And then I talked about how quartz is able to
do ultrasonics and convert light at extremely high frequencies into solitons that can travel through the ultrasonic material, and that this was discussed early 1963. And so this led me to an understanding about how potentially some, because John Hutchison was often using brass, and I have some brass samples, and I haven't got to really spend a lot of time with those, and I do want to do that on my next microscope session in America, SEM session, to really understand the brass samples. But one of Hutchison's most famous brass samples, where it's like split in the middle, just like the Russian monument on the other side in the sort of New York area to an event that occurred in the early 2000s, almost a like for like. That is actually in the Prince Hans Adam private collection, and brass, I think, it is because of its zinc and copper content. I think it's particularly affected by this in a more dynamic way than I think aluminium. Well, I don't know. They're both very dynamic. Let's put it that way. Then we talked about that. I talked about the fact that we had a piezoelectric material, quartz, which may not be piezoelectric in its fused quartz state, but it may be once it starts recrystallizing, and that may, with the ultrasonic ripple that was on the solenoid around this, interacting with the copper, produce a scenario where exotic vacuum objects were synthesized from piezoelectrics from the quartz, and interacting once they formed by emitting the 2 kiloelectron volt photons with the copper oxide from photoelectric emission, because the photoelectric emissions from copper oxide are less than, I think, 980 EV, and they are 2 kiloelectron volts. So you put out your photon and you might get 2 electrons back, and the 2 electrons come in and that chucks out more photons. So you get a virtuous cycle of production of exotic vacuum objects. And so that might explain many of the observations that were observed on the Lion reactor. And then I talked about how we had a failure, but then we'd removed the ultrasonic ripple, and then I showed that this basically is what I described in the Lion reactor is an exact analog of the later published work. It was published on February the 21st, 2019. Of the US Navy patent, where they used the most piezoelectric material, PZT, as a coating on aluminium, and they had a pulsed current source around that. So it's effectively an analog of the Lion reactor. And then I went on to how cutting stone. We have something that looks like microball lightning affecting various materials, which you would typically make like alumina and stuff like that. These are kind of things that you would, and different types of glasses that you would make building materials from. And then the structure of natural ball lightning, damage in various real events of that, and how these are practically one-for-one matches in terms of the overall look and the vortical structures that you see on it, and the fall off with the event horizon, and the hexagonal structures that you see, and the slightly lopsided view that you get with the kind of paisley that I've discussed before, that we've seen in various different experiments. And then I closed out by saying that if we can do this and cut and end up with these glassy stuff that I referred to earlier, this glassy stuff, this would explain observations in some types of modes of construction in megalithic structures through history. And I also said that I've been working my way through slide 90 for some time now, but I think it's probably because I want to talk about this particular slide, this particular image here in more detail with reference to research that people have done and we've done recently. I wanted to basically close on this slide in the first part of this presentation. So that's that. Oh, thank you, Corky. That's very generous. Okay, so did you have a question for what you've put there? Oh, cheers. Oh, this is very nice. Okay. You're number 3. You're the third person to give this channel a super chat. It's very kind of you.
Jason Smith, how close are you to a working design utilizing this test? Watch the second half of this presentation. Question, Bob, would you consider flying to Canada someday in the future? I hope to be there to work with another claimant, in fact two claimants, not claimants, people that have done volunteer work for the MFMP and or shared their work. So that might happen as soon as I can travel. The only thing that's restricting me from travel, the only thing, are governments and fear, which is unfounded. To make it clear, I had my infection, as far as I know, when I lost my smell and everything, it's well documented, over a year ago. In the recent last 4 weeks, I've had an antigen test and an antibody test on day 1 and day 2. And I was negative on the antigen, so I didn't have it. And antibody, I was positive in terms of I have antibodies, and in my view, they're over a year old. Okay? And I did those 2 tests, because I was in a house with someone who had had a polymerase chain reaction PCR test confirming that they had the current infection of the virus. And I experimentally attempted over the last 3 weeks to get infected with my antibodies. And I failed. So what I can say is I can't infect people and I can't get infected as far as I'm concerned. And so the only thing that's getting in my way is tyranny. Gordon Doherty, the interaction of those 3 vortices is the point of interest. Maybe the 3rd vortex is used to control the rate of consumption production of the first 2. So yin yang plus. You need to look a little bit further. Okay, I want to see who can get it before tomorrow. Actually, no, because I'm not even going to discuss it tomorrow. So you probably got till next Sunday, actually. You will get it. You will get it. And go and look at some of the ultra experiments. Study what you're seeing, what I'm trying to show you in there. Thanks, Brad. WP for truth question, Bob. When a system is created that can transmute at will, growing any metal will be a matter of recipe or formula. Yeah. There's a whole presentation I need to do, and it needs to be referring to observations that John Hutchison had with things that I said at the review of the Sapphire presentation in late 2019. If you go and look at that, that'll give you a hint. But I need to build to that so that it's just what I'm trying to do in the presentations is I'm trying to make it so that it's basically open and shut in terms of all of the data is consistent. It has to be self-consistent. There has to be a common factor. There has to be a common mechanism. because if you put some things in, it doesn't matter what the temperature is, you get the same answer. So nature is doing the same thing. It's all the same thing. It's always doing the same thing. It's just the temperature aspect is kind of like arbitrary. But I have said in the past, and if you go and look, I think I said it in my ASTI presentation, but it's kind of like, I certainly said it in the kind of like social times around it, that it's kind of like having charismatic leaders. You've got like Muhammad, Buddha and Jesus, and you have this prima materia, this proto-matter. What did Ken Shoulders called it? He called it the source of all matter or something, or the mother of all matter. I refer to it as basically nature, but it's the nature of the thing that's the mother of all matter. But the alchemists would call it, I think, prima materia or something like that. But when the prima materia is like a load of children that don't know which pop star to follow, or which football team, or which television cartoon program they want to see, and as they're trying to decide, they get exposed to something, and the thing that is there forms a template for them, and then they become those things. And because S.V. Adamenko talked about how after the electron nuclear collapse, single atoms form stably, and they get ejected, and if they're a single atom, they are exact prototype for the prima materia to become. And so you could probably force function this by having what the alchemists would call the Philosopher's Stone. And the Philosopher's Stone, you have a different one for the different material that you want the prima material to become. But I think whatever you do, you can't avoid having so much carbon and oxygen being synthesized. So it would always be a proportional outcome, because the thing wants to create the materials for life preferentially. It's a wonderful inherent and innate nature of what it does. It wants to create the elements for life. If you force it too hard, it will create transuranics and even things that don't exist in our near universe, as was observed by S.V. Adamenko. Go and look at his 700 and something page book, Nuclear Synthesis. If you can afford it, it's in the hundreds of pounds, but hundreds of dollars. But anyway, the point being is that but the thing is that this explains why you get a blob of gold, a blob of zinc, a blob of this. It's like if it was all producing an average thing, then it would produce blobs with all the elements of the periodic table. But you, like, even in the Echo foil making samples, when we looked at the SEM there, you had a strip of palladium and you had a bit of gold, but in terms of the amount of material in the whole thing, it was very small, and it was only in the strike points where the EVO was disheveling, as it were. And you see that on the what I call the O-Lion Nebula. Go and look at that in my discussion on that in my Sochi presentation, where you get resonant nodes, and the resonant node is actually wholly and entirely a different material, as far as you can determine from the SEM. But the bulk of the material might be nickel, but there's a blob over here and it's like a heavier metal, and it's a sphere and it's on the resonant node, and over here and it's kind of like there is resonance and there is templating going on. If I wanted to be transhuman, which path do you recommend? I wouldn't be transhuman. What you need to be is human, and we have this ability to connect with all life, not just other animals. We can connect with other life, and you have to let them into your space, and to do that you have to love, and love has to be it has to be real love, and you can't love an inanimate object, but you can love an insect, you can love a plant, you can love, even though a plant might not be animate, it is alive and it has a life force, and you can love that, and you can love a pet. So you can even love a spirit of something that's already existed, because, as I say, I don't believe they die. They're there. They're in the overall condensate of the energy field, and so you can connect with that. So people say you've got to open your heart to Jesus, let's say, but you can connect with his spirit, and you open yourself to him and let him into your life, as it were. It's true love is not lust. It's not the desiring of the flesh. It's not the desiring of the thing. It's the desiring of the possession. It's opening up your I liken it like this, and I will do a blog on my blog, but it's kind of like you have a cryptographic key, and when you love, you give that cryptographic key to that other being, and you permit them to use it for a time, and you can revoke it, but during that time you are entangled. Your spirits are entangled, your energies are entangled, and when that is true, you can feel what they feel, even if they're on the other side of the planet. And there's no time. There's no time for that information to exchange. You become coherent with that. Your spirit becomes entangled and coherent with theirs. I've discussed this before. The aim is to try and get people to not have a relationship with their unborn child, not to have a relationship with their children, not to have a relationship with their partner, or to be that relationship to be dysfunctional or just functional, by doing that, then the person is an individual and they can be manipulated. You are powerful together. Oh, thanks, Brad. Hey, number four. So Brad, you said, I love real science being done in the lab rather than speculation followed by equations. I said that I would try and do this without a single equation. I've referred to many papers that in the paper they have the equations. And I like the fact that in Palkamov's book, for instance, Space Earth Human, he has all the equations to prove the maths and everything, and how you calculate that this is what it is, and so forth. But he even says, like, if you don't want to look at the maths, you can skip to this point. But you know, if you do, it's there. And this is how you build the experiment, this is how you conduct it, and this is how you build the detector, and this is how you determine what's going on, and so forth. So I kind of like that. And as I've said before, if my 5-year-old, who's now 6, by the way, can't understand it, then we've got a problem, because you have to be trying to aim for that. That's why I love the ultra experiments, because you know they can be done within a primary school setting for nearly a lunch budget, that's the kind of level it needs to be at. And I think the idea of sticking balloons on a cat is you got to have a look at those videos. They're hilarious. Corky, I put love into art. It works, yes. And
my wife says she puts love into her food making for her bistro, and you can tell the difference, and her customers know that that's what's going on. It really makes a difference. You can, and that is about sending your intention forward to your customer, who you might not have even met your customer yet, ever, but the intention is that they enjoy your food or your artwork or whatever. So bye, Jay. I'm going to go because it's now half midnight. Guardy Pierre, just wanted superpower so I can explore the universe without dying through the harshness of space. Well, you can explore the universe through astral projection. But anyway, these things, if you play your cards right, I'm firmly of the belief that they're all available to you when you pass from this mortal coil. Corky, sometimes it's important to have a near-death experience. I had one on the top of Mount Kinabalu in Sabah state of Malaysia, and it makes you think. So I encourage you guys, Jason, sleep. I'm going. Have a good start to your day, Jason. Listen, I encourage you to see the next presentation. I think it's going to be an absolute stonker. We're going to do something on this paper, and I think we're at the point now where we can start. Well, there's many ways we can go. The barrier is you know, for certain things, the barrier is the people who would not want you to do this. But I think what we can, I think we can lay out both the process of discovery, layering on what we discussed today, and all of its rich tapestry spanning back to, as I showed you, 1963, and I even mentioned the 1892 Tesla carbon button, and that is also relevant. With the silicon carbide, this rich tapestry of information fed into what I want to share with you tomorrow, and I want to thank the researchers for doing what they did over the last years to make it so clear. And I think we're in for a really special time. I said it's going to go quite fast from last year. And I think we are going to go quite fast. And we just have to avoid the people that already knew this or thought that they knew this or don't know this but want to make sure no one can actually use it from retrospectively awarding themselves patents. So just be on the eye out for these magical patents that seem to be popping up. Because either humanity needs a solution or they don't. If they need a solution, then let's do the solution. If they don't need the solution, stop putting fear into people and finding excuses to tax them and control them. So, buonasera, buenas noches, dobronoc, do svidania, goodbye, arrivederci. I'll see you later. Thanks for your time.